Oh yeah, so this is gonna be basically your session today. Okay,
Oh God.
it's all good. It's all good. You got 8 questions. All right, let's roll. So, chapter 10 review, right? Ch Question one. Which type which type value on the spanning tree mode type global command enables the use of rapid spanning tree protocol? Is it A, rapid PVST? Is it B, PVST? Is it C, RSTP? Or is it D, RPVST? And let me explain the question again, right? Because I think how it's worded and how I said it is kind of confusing. This is as if you're going into a switch, right? You're going into global configuration mode, and you want to go ahead and change the spanning tree mode type to either, maybe multiple spanning tree protocol, rapid spanning tree protocol, what have you. What does that command look like within a Cisco switch?
Okay, for rapid spanning tree,
Hmm.
um, and used to enable RSTP.
Hmm. You can look through your books if you need to, or Google it if you need to.
Um, okay. Um, what's that value on the spanning tree mode type global command enables the use of RSTP. Um, I want to say it's C, but RSTP rapid. I think it's C, rapid spanning tree.
Okay,
Oh,
final,
okay.
final answer.
Yes.
Okay, that is incorrect. So the command that you type in would be A. It'll be rapid dash
Why I thought.
PVST.
Oh,
Remember,
okay.
remember, remember during theory, right? So, and this is how you remember this. In theory, right? If Cisco went ahead and combined rapid spanning tree with P per VLAN spanning tree, right?
Oh, it's per VLAN. That's
Yeah,
yeah. I
yeah,
didn't know what the
yes,
PVST per
yep,
VLAN spanning tree.
yep, yep, yep.
Oh,
So
okay, so it's
it's all
A.
good. Yep, it's A. So it's all good. It's all
So
good.
when it's already configured, it shows the C then, right? That's what I've seen before.
Say it again.
Or no? Like when rapid spanning tree is already configured,
Hmm.
doesn't it show up in the configuration as C, RSTP?
You're correct. Because look right here, right? So if we look down here, you see if we do a show spanning tree, then it's going to say spanning tree enabled protocol, and it's going to show you the type right here. And that's where you see RSTP.
Okay.
But when you enable it, it's going to look like this whenever you're
Okay.
configuring it. Does that make sense?
Yes.
Okay, cool, cool, cool. All right, so let's look at question two. Examine the following output from the show spanning tree VLAN 5 command, which describes a root switch in a local area network or a LAN, right? Which answers accurately describe facts related to the root bridge ID. Choose two answers.
Okay.
All right, and I'll let you
Okay.
read.
The system ID extension value in decimal is 5. The root's configured priority is 32775. The root's configured priority is 32768. The system ID extension value in hexadecimal is what it shows in the screenshot. Okay, so it's B and D. So it's the root configured priority value is the 32773, and then the system ID extension value in hexadecimal is the 1833.
You said B and D.
Oh, wait, hold on. Wait,
Okay.
let me read that one more time
Uh-huh.
because the address, that must, is that the MAC address? The system ID extension value. Well, I mean, it says root ID. Yeah, I'm still going to go with B and D.
Okay. Positive.
Wait, no. Hold on. The
Okay.
system ID extension value in decimal is 5. Okay, now I think it's A and B
Okay. Positive.
because Yes.
Okay. All right. Is that your final answer?
No, it's not. I want to
Uh,
change it back to B and D.
all right.
Wait.
With that being said, your answers are incorrect, and the correct answer is A and C. Let's break it down
A
as to
and
why.
C.
A and C.
A and C.
A and C.
Where
So let's break it down. Let's break it down. I'm gonna go ahead and help you.
73.
Right. So A, right? The system ID extension value in decimal is 5. Okay. So this is saying show spanning tree VLAN 5. The system ID extension is the VLAN number. Okay. The default number, right? The default number of a priority, right, for a bridge ID is 32,768. If you add 32,768 plus 5, what does that give you?
Uh,
32,773, right?
that makes okay. So that makes sense because a D is not the answer because that's actually the MAC address. Is that right?
Yep, exactly. So that is not the answer.
Oh,
Okay.
aggravated.
It's okay. It's all good. You're learning, right?
Okay.
So A, and then let's look at C, right? C, the root's configured priority value is 32,768, right? How can you determine this? And this is where Mykevia needs to go ahead and I forgot the term for it, but you start viewing some, being a little bit intuitive about this, right? So you see this and you say 32,773. What's that minus 5, right?
Oh,
32, right? You do that minus 5,
32768. Oh.
boom, boom. There you go, right?
Okay, the system ID extension value is basically the VLAN ID, like the VLAN
Mm-hmm.
number.
Yep.
Okay.
Yep. Okay. All right. Did that make sense?
Yeah, it
Okay.
does.
Okay. Cool, cool, cool. All right, let's go ahead and go to 3. I know, I know. Let's go ahead and go to 3. So 3, with Cisco's RPVST plus, which of the following actions does the switch take to identify which VLAN is described by a bridge protocol data unit? Choose 3 answers.
Okay, hold on. What information does a search take to identify which VLAN is described by a BPDU? As a VLAN tag when forwarding a BPDU on trunk, adds the VLAN ID to the extra TLV and the BPDU. Choose 3. Okay. List the VLAN ID as the middle 12 bytes of a system ID field of the BPDU. Hmm. I think it's A, C, and D. Um, because I don't know what an extra TLV is.
Okay. So you
That's
said,
probably wrong. So, and I might add, I'm not using Google. Okay, this is straight
okay,
off the dome. So,
okay.
and it's probably wrong. So, wait, let me reevaluate my answers again.
Yeah.
Um, mm, okay, I'm gonna stick with my answer A, C, and D.
Okay. All right. So you said A, C, and D. So that is
Mm-hmm.
incorrect. Okay. All good. Let's break this down. All right. So A, right, adds a VLAN tag when forwarding a BPDU on trucks. That is correct. Okay. He said C and D. So let's look at C.
Mm-hmm.
C lists the VLAN ID as the middle 12 bits of the system ID of the bridge
Don't even
protocol.
sound right.
but
It's A,
but
B, and
let's
D aggregated.
but
uh,
let's break it down, right? So and this is why that like it's very important to go ahead and take a look at that as far as because they actually break down the 2 bytes and the 6 bytes, right? Within the chapter as far as what that bridge protocol data unit looks like, right? So what this is saying at at C is the system ID field, right? To go ahead and to to show that the VLAN exists within a bridge protocol data unit, that it takes 12 bits to do so. That's a lot of bits for a system ID. That's insane, right? We don't need that
right,
much. And two, that's not within 2 bytes. Make sense?
right. Yeah, that's
Okay.
12. Okay.
Okay. All right. So the correct answer is A. B, right, adds VLAN ID and an extra TLB in the BPDU. And of course, D lists the VLAN ID in this system ID extension field of the BPDU. Okay. All right. Let's move forward. All right. A switch port in access mode connects to a single laptop. An attacker replaces the laptop with a local area network switch that uses STP. Which combination of features enabled on an access port results in the switch changing the port interface state to error disabled? Choose 2 answers.
Okay.
Now take your time with
Switch,
this.
switch port and access mode connects to a single laptop. An attacker replaces a laptop with a LAN switch that uses STP. Which combination of features enabled on the access port results in the switch changing the port interface state to error disabled? Port fast enabled but BPDU guard not enabled. Both enabled. Truth two. Mhm. Error disabled. Hmm.
Just to check, right? You know what error disabled means, correct?
Like the switch port is disabled, like it's disabled, and it's not
Yes,
like administratively disabled. It was due to a change or something.
that's correct.
Something
So
right.
a condition was met, right?
It's like a detected problem, I guess. On the
Exactly,
port.
exactly, right? So yeah, so it shuts it down so it cannot receive any fast link pulses. So yeah, you're correct, right?
Okay.
And remember, we did a lab on this on port fast and BPD guard, right? But again, the question is asking you choose 2 answers, right? And you want to think about conditions. What conditions have to be set so that it can fulfill the question that's being asked?
Okay. Hold on.
Mhm.
Um. So okay. So it would be the BPDU when it's disabled. So I think it's two. So I think it's A,
Okay.
and
Just remember,
so port fast.
read the question again, right? And keep in mind and ask yourself. And again, you can Google it if you need to, or look inside your book. understand what port fast does, and truly understand what BPDU guard does.
Okay. I think it's A and C. Because if someone connects to that port and a
Let's think. Let's think
huh?
about it. Let's think about A.
Okay.
Port fast enabled, but BPDU guard not enabled. What is port fast doing? Right? Port fast, right? What it does to the STP convergence process, it is removing, right? It is removing two steps, listening and learning, so that a host can immediately go to forwarding from blocking, right?
Okay.
Okay. BPDU guard, what is that doing? BPDU guard is you're where the switch, right? The control plane is telling that switch port, if you receive any BPDUs from another switch on this port, I want you to
It's disabled.
disable this port. So,
Okay.
with that being said, why would A be the correct answer?
Okay. That's enabled. Okay, so A is not one of the answers.
Okay.
Okay. Hold on. Well, if the BPDU guard is enabled, then it's not going to go into arrow disabled.
Yes, it is. That means the condition was met, right? Based on the question, right?
Mm.
An attacker replaces a laptop with a LAN switch. That switch is sending BPDUs because it to since SDP is enabled on that LAN switch, it needs to go ahead and send BPDUs. If we're connecting to that port and BPDU guard is enabled, that switch is going to say you are not able to send me BPDUs. It's going to shut that port off.
Okay.
Okay, so
So it's
so that's B, right? One of the answers is B. Okay,
so
let's
it's
look at
B and C
yes, exactly.
because the BPDU guard is enabled
hmm
on
And then if we,
both,
yep, and if we
and
look at
that can
C,
means the condition. Is that right?
yeah, it
Oh,
meets the condition, right? If you look at C, right, it says port fast is disabled, but PPTU guard is enabled. See, what the CCNA exam is going to do, it's going to try to trip you up, right? And this is why you have to make sure you understand what certain configurations are so that when you get asked these questions, right, because not everything is going to be a simulation, you can actually talk through it to yourself through words. Okay?
okay.
All right, let's go to 5. Root guard is active to disable port gigabit 1/0/1. An engineer uses the show interface's status and show spanning tree VLAN 1 commands to investigate the current status. Which answers list facts expected due to the root guard's action? Choose two answers.
Okay, root guard has acted to disable port gigabit 1/0/1. Engineer uses show interface status and show spanning tree VLAN 1 commands to investigate the current status. Which answers list facts expected due to root guard actions?
Take your
Choose
time.
two. So I would say one is C because it would be in a blocking state. Because if it's disabled, wait, root guard. No, hold on.
Read C. Okay, good.
So root guard. Okay, what is root guard? Root guard is enabled when a BPDU is like one is higher than the other one,
Yep,
right?
you got the right concept. Yep.
Okay, so there's a priority on this port which caused it to be disabled. So I would get an error disabled on this port, right?
Mm-hmm. Right. So, and let's read through the question, right? And let's think about what root guard is, right? Exactly what you said, right? What root guard is, right? If we enable that on a switch, right? The thing about the thing about
Oh, it
whenever
cannot be.
so the
Okay,
thing
sorry.
about that is no, you're good, you're good. Is that whenever a switch, right, it receives a BPDU because it's listening, right? It's listening for to that multicast address that's receiving BPDUs, right? So if it sees a BPDU that has a superior, right, um, a superior value than itself, right? And of course, how to remember, lower is always better at layer two. Better is higher at layer three, right? So whoever has the lower, right, value is better, right? So if it sees it and it has a superior value than itself, right? What root guard is going to say is even though you have a superior value, you're not supposed to become the root, and you're not, and this port isn't going to become the root port. I'm going to go ahead and disable this port, right? Okay. So for this question, right, the switch, right, the switch port on gigabit 1/0/1 received the BPDU that was superior than its own switch. Okay. So it disabled the port, right? So the engineer, like let's say it's you, did a show interface and status and did a show spanning tree VLAN 1 to investigate, right? So what would we see, right? First things first, what we're going to see, right, is the spanning tree port state per show spanning tree VLAN 1, right? Because that's one of the commands we're going to put in. It's going to show has broken, right? Because in a normal
Because of
state,
that superior one, the
exact,
superior BPDU.
exactly,
Oh, okay.
right. In
So
a
it's
normal
not
state,
blocking, it's broken.
it's
Okay.
broken, right? In a normal state, it's going to go ahead and immediately converge, right? Since we're setting up root guard, we're saying do not create a loop-free topology on this port. I'm going to set it to broken. Okay. Let's move down to answer E. The interface status state per show interface's status shows connected. Okay. It's still layer one is fine. Layer one is fine. but that doesn't mean layer 2 is working. Make sense?
Yeah.
So for this question, right,
It's
is
gonna
that
be A.
you have to understand it's going to be A and E, and you have to understand what these show commands do and what root guard do. Layer 2 is very heavy on this exam, right? Because typically
Your
those that
iPad. Sorry.
no, you're good. Those who do, right, or that are trying to
Mm-mm.
become CCNAs, you're typically doing a lot of land work. Okay. All right. Let's go. We got two more questions. All right. Question 6. No, 3 more questions. An engineer configures a switch to put interfaces gigabit 0/1 and gigabit 0/2 into the same layer 2 ether channel. Which of the following terms is used in the configuration commands? Is it A, ether channel, B, port channel, C, ether channel, or D, channel group?
Okay. Hold on. Hold on. Let me move. Sorry. Hold on.
You're
I
good.
don't know if you can hear my background. Hold on.
Very good. Mike, I see you join. What's up, brother?
Oh my God. Please call. Oh my God. I'm getting cooked. Okay. Uh,
What's up, Dave?
What's up, brother? How you doing?
I'm doing good, man. How about you?
Hey, man, we're good. We're in this review. If you want to jump in, you know, let me know.
Oh yeah, I'm actually sitting my CCNA getting recertified this Monday, so
Okay,
I'm
okay,
I'm listening in. This is
oh,
good stuff.
wow.
okay, cool.
Okay.
And you
Hold
know what?
on.
What I'll do, Mike Hebe, I'll give you a break. And since Mike got his CCNA coming up, Mike, I'll give question 6 to you. So, what do you think the answer is for question 6?
It's channel group.
My man, awesome, right? So, at the interface level, Mike Hebe, you remember we did the lab, right? To go ahead and create Ether channel, we need to go to the interfaces, right? And go ahead and put the command, of course, upon we have some other commands to do. But to create that ether channel, we need to put in channel group, the number, and the type of ether channel, either a static one or a dynamic. Okay.
Okay. Yeah.
All right. So
I got it.
make sure you review go ahead and review that. Mike,
It's C,
questions.
right? Ether channel or ether group?
It's
No,
D.
D. Channel group.
Channel group. Yep.
Okay. Okay.
So look that up. All right, let's go ahead and do 7. All right, Mike, which combinations of keywords on the channel group interface subcommand on 2 neighboring switches will cause the switch to use LACP and attempt to add the link to the ether channel? Choose 2 answers. And I like this just to take a pause. I like answer questions like this because it absolutely tests and makes sure that you actually are doing labs. So, Mike, you're on the clock.
It's active and passive and active and active.
Okay, so B and D. And your final answer?
Yeah.
All right, that is correct. Okay, all right. So, question 8. A Cisco Catalyst switch needs to send frames over a layer 2 ether channel. Which answer best describes how the switch balances the traffic over the 4 active links in the channel? Mike.
Um. I'm just reading.
No, go ahead. Take your time.
Percent utilization of the next.
I'm gonna say B.
You said B.
Yeah.
Okay, so okay. All right, so let's read this out. B sends the entire frame, okay, sends the entire frame over one link, alternating links in sequence for successive frames. So what we're saying is, right, it sends the frame over one link, right? But if it's, let's say it's an entire packet that's being broken down, you're saying it's switching, right, different links within sequence, right? You're saying that's what the switch is doing within the layer two ether channel.
What was that again? Can you say that again?
So what you're telling me by choosing uh by choosing question answer B is that the switch, right, whenever it receives a frame, right, and it's a packet, right, but it's breaking down to layer two. It's going to go ahead breaking down that packet into a frame. It's going to send it on alternate links in sequence, right, in order, right, for each successive frame. So each frame that reaches, right, that it gets from breaking down the packet, it's going to pick different links. Is that what you're telling me for the entire session?
No, that's not what I'm telling. Nope, that's not what I'm
Okay.
telling. Yeah,
Okay.
that's wrong, dude.
Okay. No, it's okay. It's okay. So because sometimes, right, and again, I had to learn when I was taking the exam, and even taking the CCNP, I have to read it out loud, right? Because I can lab all day, but if I don't read it out loud, I'm like, oh no, that's not what it does, right? Okay. So you said not B, right? Let's read C. Okay. Sends the entire frame over the link, over one link, right? Choosing the link by applying some math to fields in each frame's headers, right?
um,
So
that will be it. I think that's it right there.
that would be it, right? And just to
Yeah.
How though?
I'm going to tell you, right? So at the CCMP level and above, right? What the Ether channel does, it performs a XOR algorithm, okay, with Ether channels, right? Whenever you're, creating an Ether channel or building that design for Ether channel, design is very important with that, right? Along with choosing, I'm sure you remember at the end of the chapter, if you read that it goes over the different methods, right? The different strategies that you can have, right? In regards to the math, right? But the math manipulating what link to choose, right? Because the the index, right, that is used, right, to go ahead and do the math is each link. Let's say we have an ether channel of 8 links. Each link has an index number starting at 0, right? 0, 1, 2, 3, 4, 5, 6, 7. Okay. If I pull out my calculator, right? All right, I'm gonna nerd out real quick, okay? If I pull out my calculator, right, and I say, let's go ahead and send a frame over link 0. Okay. All right. So the frame is just going to be 0, right? If it matches up, right? If doing the XOR um, calculation, boom, it's going to win, right? Let's do 1, right? Oh, let me erase that. Let's do 1. Let's look at it in binary, right? So now I'm gonna use 1 0, right? That's the field, right? And it's going to go ahead and say, what's equal to 1 0? Okay, I'm going to send it over link 1. Excellent, right? So not link 1, right? But we gave link 1 the value to link 2 within the ether channel. Let's look at 2. All right, let's do that. And what is that? Oh, let's change that. Jesus. And boom, there we go. Yeah, nope, that's not. Let's. Jesus Christ, why is this doing this? Clear that. For that. Okay. If I knew what my calculator was doing, okay, switch that. And then let's switch it back to programming. There we go. All right, boom, right? So we have a new bit value for 2, right? That's going to give us 1 0. I have a new bit value. Probably have to keep doing this because it's being goofy. I have a new bit value for 3, 1 1. I have a new bit value for 4, 1, 0, 0. All these values, right, is going to be matched up, right, with the last 3 bits, right, or 4 bits within whatever methodology I'm using, whether it be source IP address, destination MAC address, source MAC address, right? Then what the switch is going to say, excellent. Depending on those last 3 bits, does it match up with 1, 2, 3, 4, 5, 6, 7, 8, or whatever links that we have, right? And based on that number, does it match this number? Then if it does, that's the link based on that index and based on this link, I'm going to send it out of that link. That is the math that it is doing to each frame's headers. Okay. Now, do you guys need to know about XOR on the exam, on the CCNA exam? Absolutely not. Right. But you will need to know this. Sends the entire frame over one link, choosing the link by applying some math to fields in each frame's headers. Okay. That makes sense?
Yes.
All right, guys. Well, we'll go ahead and end here, and I'll see you guys on Sunday.
Alrighty. Thanks, David. Bye,
Later,
guys.
guys.
Bye, Mike.